giving this question to you. Okay. So again, there is a pentagon. Okay. 1, 2, 3, 4, 5. Again, there is a pentagon. But now we want to find the electric potential in a 3D, on the axial line. Okay.
Yes, sir.
So this is a pentagon of side A. Okay.
Yes, sir.
There is a point P at a distance x perpendicular to the plane of pentagon.
Yes, sir.
Point P is at a distance x perpendicular to the plane of pentagon above its center. Okay.
It will be 5 times of KQ by.
Yeah, I want you to find what is the potential at point P. Get the final expression for potential at point P. Side is it's a pentagon, and there are 5 identical.
If you write potential at point P, won't it be infinity? It should be
Find
due to the other thing.
find electric potential at point P.
Then if you take at point P, won't it be in infinity? Because we consider the potential of that point also.
There is no charge at point P.
Yes, sir.
If there is a charge at point P, then it will be infinity. The charges are there are 5 charges placed at the vertices of a pentagon. Find the electric potential due to these charges at point P.
Sir, 5 times of KQ divided by, under root of a square by 4 sine square pi by 5 plus x square.
What is this question number? 8, 7?
8.
8. So, you're saying 5 times of
5 times of KQ
upon
divided by
under root of
a by under root a by 4, a square by 4. A square by 4 sine square pi by 5 by 6.
Yeah. What is
5 by 5, sir.
36, right?
Yes, sir. 936. Some root 5 plus 1 by 2, I don't know.
Huh?
I don't remember.
Don't remember what?
Sine angle. Sine 36 value.
No. We do that in trigonometry, I know. Some root 5 plus 1 by 2 or root 5 minus 1 by 2.
Yes, sir.
Yeah. The worst in mathematics, I hate trigonometry. I used to get really irritated. 9th question. So, find the electric potential due to a loop. There is a loop. The total charge on the loop is Q. Okay.
Yes, sir.
It's a uniform distribution. That means we are saying that lambda is constant. Okay.
Yes, sir.
The radius of the loop is R. At a distance of x above the center of the loop, perpendicular to the plane of the loop. Let's say there is a point A. Find the potential at point A.
Yes, sir.
Actually, I will write it right away, straight. The idea is, it's
We
okay. I mean,
actually have to integrate taking small element.
yeah, but I will show it to you. See,
Okay, sir.
suppose I take a small charge dq element.
Yes, sir.
If you look at it, all the elemental charges are at the same distance from the point A.
Yes, sir.
That means my total charge is at the same distance from point A, even if
Yes,
the
sir.
shape is a loop. So if you look at it directly, if you look at it, you will get the answer straight like this,
A square plus X.
right? I mean,
Times.
clear?
Yes, sir.
But
Yes, sir.
suppose if I want to do it stepwise, first I will write, okay, potential due to this small element is k dq divided by under root of x square plus capital R square, right?
Yes, sir.
This is my first step. Then I will say, okay, v is equal to integral of dv, and simply all of these are constants. X is a constant, R is a constant, K is a constant. So I'll write K divided by under root x square plus R square outside. Yeah.
Mm.
And I'll do integral of dq, and directly instead of going into lambda and all those, directly I will say 0 to capital Q integral dq, and I'll give the answer. Clear?
Yes, sir. Yes, sir.
So of course, we will come to this kind of a stage after having good enough practice. Directly, I am able to write things only after enough practice, because I have to be sure if I'm doing right or wrong. Sometimes I might confuse myself and do wrong. There is a probability, right?
Yes, sir. Yeah. Sir, what is that diluted thing? You do something like that?
There is a
Like,
loop of total charge Q.
yes, sir.
Half of the loop is cut.
Okay.
Half of the loop is cut and removed.
Yes, sir.
Find the potential at point P, where P is
Sir,
at
what should be half of that value?
good. It will be half of the value. Basically, it will be K.
Because integration from 0 to Q by 2.
Yeah, x square plus R square, right?
Yes, sir.
Simply it is half because it's a scalar. Potential is a scalar, and lambda is also constant everywhere, so we are not worried. There is a loop of radius r, capital R. I am showing one particular line, radial line, which is at an angle theta with the horizontal line. Okay.
Mm.
Now, at a distance of x perpendicular to the loop, the plane of the loop, and
Yes.
above the center, there is a point A. I want to find the potential at point A. It is a non-uniform distributed loop.
You need to consider lambda.
Lambda is given as lambda naught sine theta, where theta is this angle that is shown in the figure.
Yes, sir.
Find the potential at point A. Okay?
Yes, sir.
I gave that easy one. So to check if you will get confused if some small changes are made. Right? Now here you'll have to do some mathematics for it. Okay? Hello everyone. Welcome to Veracious Academy. My name is Anil Kumar. I'm an alumni of IIT Bombay. I have done my BTech from Mechanical Engineering. I have been teaching physics for the past decade for JEE Mains, JEE Advanced, Neet UG, and other competitive exams. If you're interested to attend my sessions, please find the contact details in the description below. Let's get started with this lecture. Enjoy the video.
I got like lambda naught AR by under root of r square plus x square and cos theta. Like I have to take limits from 0 to 2 pi.
Let me solve it. Okay.
Yes, sir.
So at an angle theta, I will take a small element subtending an angle d theta, right?
Yes, sir.
And the charge on this particular thing, I will take it as dq. Let the length be dl along the perimeter,
Yes, sir.
right? And the
Yes.
angle subtending is d theta. Okay.
Yes, sir.
So first, I can write this dl element is equal to r d theta.
R d theta. Yes, sir.
Okay. Next, I can write it my dq is equal to lambda into dl.
Yes, sir.
Therefore, I can write dq is equal to lambda, which
Lambda
is
not sine theta.
lambda naught sine theta
R d theta.
r d theta. R into lambda naught are constants. I'll write it
Yes.
as sine theta d theta, and this is my charge dq. Right?
Yes, sir. Yes, sir.
Okay. Now,
Only that goes into integration. I mean, with
the charge.
dq by under root of r square plus x square.
Right. So the potential due to the element dq at point A is equal to simply k dq upon, like you said, the distance, right?
Under root of.
Under root of x square plus r square.
Yes, sir.
Fine.
Yes, sir.
Simply I have to bring all these stories over here and integrate, right?
Yes, sir.
So my VA is equal to integral of dVA, which is integral of this thing, which is k by under root of x square plus r square. But my dq itself is this story, right?
Yes, sir.
R lambda naught sine theta d theta. Like you said, here I have to do from 0 to 2 pi.
Yes, sir.
The limits of theta are from 0 to 2 pi. Those are the limits. Okay.
We bring everything out except sine theta dt.
Bring constants outside. This thing also is a constant, so we do not have much problem in our integration. It is simply integral of sine theta d theta from 0 to 2 pi.
Thank you. Thank you, guys. Mine is cos theta right now. Yes, sir.
If you remember, one lecture we discussed integral of sine theta actually represents in graph sine theta area under curve.
Yes, sir. But it will be 0. No. Yes, sir, because all of them will get cancelled.
Because sine theta starts from here and goes till here, 0, pi, 2 pi.
Yes, sir.
Also, what is this one fellow's area?
It
Only
will be A, and the down part will be minus A.
minus A. But how much is this area? One part. It is 1. Remember.
Okay.
Obviously, right? Integral 0 to pi sine theta d theta will become cos when you substitute the limits. It will be
Yes.
1.
Oh, yeah. Yes, sir.
Are you getting my point?
Yes, sir.
Like you said, this is plus A, this is minus A is also obvious. I mean, is also correct. But also, I want you to remember the value of it, which is plus 1 and minus 1. Same goes for
Yes.
cos theta also. Okay.
Yes, sir.
Clear?
Yes, sir.
Xerox.
I did the same thing. I won't write again.
Okay, are you done?
Yes, sir.
Here, now I'm giving one more challenge to you. There is a uniform rod. Okay. Lambda is a constant. uniform rod having a total charge Q, capital Q. Okay.
Yes, sir.
This length is given as L1 and this length is given as L2.
Yes, sir.
Also, I have given the angles. This length subtending is angle theta 1 and this length subtending is angle theta 2.
Yes,
I
sir.
have given A also, which is the perpendicular distance from the rod. Okay.
Hmm.
Why I have given L1, L2, theta 1, theta 2 and A is you use anything as per your wish. I am giving you everything, right? How you take an element and how you're going to do your substitutions and all those things, how you're going to use your geometry is a complete freedom to you.
Yes, sir.
You have L1 and L2 also, you have theta 1 and theta 2 also, you have A also, you have total charge Q. Okay.
Yes, sir.
And lambda is a constant. Find the potential. Let's say if this point is C. Find the potential at point C. Okay.
Yes, sir. Then I got K lambda integration of secant x from minus theta 1 to theta 2.
Let me solve it. It might be right, it might be wrong, I'm not sure. I'll start. Okay.
Yes, sir.
See, we can also treat it as a derivation for our own thing. Electric potential due to a rod.
Yes, sir.
Now, let us say how will we take. First, I will choose a reference, right? For calculus, song
Yes,
is
sir.
important. So let me take this point as the reference, and from this point at a distance of x, I will take a small element of width dx, having
Yes,
a
sir.
charge dq, right?
Yes, sir.
And now I will find the potential due to this element at point C, right?
Yes, sir.
If we look at this right angle triangle, so this length is A, this length is x, and my charge d, my charge dq is over here, and point C is over here, right?
Yes,
And
sir.
hypotenuse is square root of a square plus x square, correct?
Yes, sir.
Now, the potential due to the element, I will write it as dvc is equal to k charge is dq upon the distance, right?
Yes, sir.
X square plus a square.
Yes, sir.
Now,
Lambda is dq by dt.
therefore dq is equal to lambda dx. Correct?
Yes, sir.
So
Yes, sir.
simply I will get this as k lambda
dx.
dx upon. Now I have a variable in the denominator.
I can't remember.
Correct?
Yes, sir.
Actually, this we can integrate left hand side, right hand side, right? So we will have Vc is equal to integral of dvc, okay, which is k lambda is constant, it will be outside, integral of dx upon square root of a square plus x square, right?
Then we take tan theta equal to.
Yeah, fine, correct. So I'll take this angle as theta, and from this, using this geometry, I'll make my substitution as x is equal to a tan theta, right?
Yes, sir.
Therefore, my d is equal to a
square
secant square theta d theta,
a secant square theta. Yes, sir.
right?
Yes, sir.
So what will I get it as? K lambda integral of dx is A secant square theta d theta upon square root of
A secant theta.
A secant theta. Which will give me k lambda. A is also outside. Actually,
yes,
A will get cancelled, right? In the numerator.
A will get cancelled.
A will
Yes,
get
sir.
cancelled in the numerator and denominator. So simply we have k lambda. We'll just write it over here. Integral A secant square theta d theta divided by A secant theta is nothing but integral of secant theta d theta.
I don't know what is integration of secant theta.
Integral secant x is ln mod x plus a. There is a formula for that.
Okay.
Let us check in Google. We can do it using we can do it using more substitution and all.
First we have to think which differential will give that one.
First we have to
think which differential will give secant theta.
Yeah. So integral secant x is ln mod secant x plus tan x. Okay. I mean, once integration is done to you in mathematics, then you will remember all these things. Ln mod secant x plus tan x plus c, obviously. Okay.
Yes, sir.
So here the limits for theta is minus theta 1 to theta 2. Okay.
Yes, sir.
So basically I have k lambda. Integral secant theta is ln mod secant theta plus tan theta. So first let us write that. Ln mod secant theta plus tan theta. And the limits are from minus theta 1 to theta 2. You remember the minus, right?
Yes, sir.
Because it is in the reverse direction.
Yes, sir. Because it is anti-clockwise.
Correct. Here we are taking anti-clockwise as positive. Reference line for my angle is the vertical line. So any clockwise direction from the vertical line will be negative.
Yes, sir.
So k lambda, if you remember, for ln, when I do upper limit minus lower limit, I can write it
a by b.
A by b. So it is ln of, I'll directly write it. First theta 2 is secant theta 2 plus tan theta 2. Okay. Divided by secant of minus theta 1. Cos of minus theta is cos theta. Right? So this will still be secant theta 1.
Plus, no, it will be minus.
Minus. Tan will become minus. So minus tan theta 1 is our answer. We see. But total charge, if I want to write in terms of total charge, okay, so lambda actually is what? This
L1 plus L2.
L1 plus L2. So simply I have to substitute that. So basically I have KQ by L1 plus L2 into ln secant theta 2 plus tan theta 2 divided by secant theta 1 minus tan theta 1. Clear?
Yes, sir.
I will also discuss extension of this. Okay.
Like we took the special cases.
Okay.
I did the same thing till the last step, sir. I noted after.
Till here.
Yes, sir.
Now you just have to take this down.
I wrote it while you were writing.
Oh, you're done?
Yes, sir.
Okay. So what I am saying is, if you remember, we will remember this lambda thing, right?
Yes, sir.
Because it is useful for us in application part.
Yes, sir.
Now, in this only, if we have cases, so case 1, let us say I have a semi-infinite wire. So for semi-infinite wire, I have figure is something like this. This distance is A, correct? And this is lambda.
Yes, sir.
What are the values of theta 1 and theta 2?
Theta 1 is 0, theta 2 is 90.
Theta 2 is 90. So therefore my VC is equal to K lambda. I just have to substitute my theta 1, theta 2 values here, right?
Yes, sir.
Cos 90 is
1. No.
0.
0.
So secant 90 is
Undefined.
undefined. So we'll have to change this, I think, right? Can we change it? No. ln of undefined.
Total infinity.
Yeah. ln of undefined will be undefined only completely. And here we have secant 0. Cos 0 is 1. So secant 0 will be 1. And tan 0 will be 0. So denominator is 1. Now numerator tan 90. Tan 90 is also infinity.
Yes, sir. Infinity.
Secant square theta minus tan square theta is actually 1. But this becomes undefined.
Yes, sir.
This becomes undefined. So let us say that this becomes undefined. Okay.
Yes, sir.
We'll take some general case. See, also if you look at it in terms of physics, when you have a semi-infinite wire, that means there is infinite charge and potential is a scalar. So you're adding 1 plus 2 plus 3 plus 4 plus 5 plus, let's say,
It will tend to infinity.
it will always tend to infinity, right? Let us take some other
We don't know
case.
where we have to stop.
Yeah. So suppose there is a rod of length.
Infinite wire also will be that only.
Hmm?
Infinite wire also will be that.
Will be that only. So suppose we have a rod of length 2a. Okay, from here to here. So obviously what I'm trying to show is that this is 45 degree, this is 45 degree, right?
Yes, sir.
Let us take this as lambda.
Root 2 plus 1 by root 2 minus.
Right. So basically my if this point is C, let's say, so potential at that point C is equal to, I'll have K lambda ln mod of Secant 45 degree, right, is root 2.
Yes, sir.
And tan 45 is 1. Okay, so you said root 2 plus 1 by root 2 minus 1.
Yes, sir.
Good. Hi guys, I hope you enjoyed the session. If you think this video was useful, don't forget to like, share and subscribe to my channel. Also, I'll be waiting for your comments in the comment section. See you in the next video.